Okay, Mr. Woods, if you would like to have them do the bell assignment, you may pause it at this point, have them put their answers on the board, and then go over those with them. What we're talking about today is Lesson 60, the area of a parallelogram. Recall that to find the area of a rectangle, we multiply the length and width, which are perpendicular dimensions of a rectangle. Okay, remember we talked the other day about perpendicular, meaning that it meets at a right angle. So we multiply the length and width, and we know they're the length and width because of where they are perpendicular. Also, recall that to find the area of a triangle, we multiply the perpendicular base and the height as the first step to calculating the area. Then we find half of that product. Okay, so the rectangle that they're talking, or the reason that we do this is because we're starting with that rectangle. So whenever we take the perpendicular base times the height, they're talking about taking this distance times this distance. Well, when we do that, this distance here is the same as the height here. Okay? And the reason that we take half, then, we know that the area of a triangle equals half the base times the height, or we say base times height divided by 2, same thing. But the reason that we have to take that half is because whenever we multiply the base times the height for this triangle, we're getting the whole triangle. Or not the whole triangle, the whole rectangle, excuse me. So we take half because this portion of the triangle is exactly half of this portion of the rectangle. And this portion of the triangle is exactly half of this portion of the rectangle. Whoops. Likewise, to find the area of a parallelogram, we multiply the perpendicular base and the height. Again, the product is the area of a rectangle, but the area of the rectangle is equal to the area of the parallelogram. In the figure below, notice that the part of the parallelogram outside the rectangle matches the missing portion of the rectangle. Okay, so we filled in here so that we have this whole rectangle. And really, whenever I did this, I should have just had, whoops, let's just go ahead and bring that down, this part rotated around to show that this portion of the parallelogram matches exactly with this portion that's missing over here. So this portion over here we can just cut off and put over here, and if we did that, then this wouldn't be here anymore, and then we would have this rectangle. So that's why the formula for a parallelogram is exactly the same as the formula for a rectangle, which is area equals base times height. Wants us to find the perimeter and area of this parallelogram. Remember, to find the perimeter, we're finding the distance around the outside of the figure. Okay, we're going all the way around. So because this side is the same as this side, we know that this is 8 centimeters. And because this side is the same as this side, we know that this distance is 6 centimeters. So to find that perimeter, we're going to take 6 plus 8 plus 6 plus 8, and that's in centimeters. So we will get that the perimeter is 28 centimeters. To find the area, we know that area of a parallelogram equals base times height. So instead of my base, my B, I'm going to put my 8 centimeters. And my height, remember, is the perpendicular height. So that has to be where that right angle symbol is. So it's going to be 5 centimeters. So I find that the area of this parallelogram is 40 square centimeters. On a coordinate plane, sketch and find the area of parallelogram B, C, D, with vertices A at such and such, B, C, and D. So it's going to tell us where to, let me move this over here for right now. It's going to tell us where to plot each of our points. So point A, vertex A, is at 2, 1. 2 is my x, 1 is my y. So I'm going to go 2 on my x, so 1, whoops, here we go. 2 on my x, 1, 2, and then up 1 for my y. So my point is right here, and I'm going to erase my tracing there. So I have a point at 2, 1. My next point is at 1, negative 1, so I'm going to go right 1, down 1. Then I have negative 2, negative 1, so left 2, down 1. And my last point D is at negative 1, 1, so left 1, up 1. And then I'm going to fill those in. And then I'm going to go ahead and name them, the names that they had with them. So this is parallelogram ABCD. Now, it also tells me to find the area of this parallelogram. And remember that area of a parallelogram equals base times height. So my base here is going to be across the bottom. Okay? And it is 3 units long. So instead of B, I'm going to plug in 3. And my height is going to be about right here. You can see that this is perpendicular. So I have a height of 2. 3 times 2 is going to give us 6, and it's the area, so we're going to say square units. Then it wants us to graph the dilation of parallelogram ABCD with a scale factor of 3. What is the area of the image? Well, first of all, instead of trying to figure out how many you need to count this way and that way to plot your new points, there's a little trick that we can use. Remember that factor means that you're multiplying, okay? 3 is a factor, so we're going to take this 3, factor of 3, times each, whoops, I got stuck there. Factor of 3 times each of the vertices, each of the coordinates. So I'm going to take, for A for example, A prime will be 2 times 3 is 6, 1 times 3 is 3. B prime, 1 times 1 is 3, negative 1 times 3 is negative 3. C prime, I have negative 2 times 3 is going to give me a negative 6. Negative 1 times 3 is a negative 3. And D prime will be negative 1 times 3 is a negative 3. And then 1 times 3 is just 3. So these are my new coordinates that I can plot. So my first one is 6, 3. I'm going to go right 6, up 3. 1, 2, 3, 4, 5, 6, up 3. This is A prime. My next point is at 3, negative 3, so I'm going to go right 3, down 3. That is at B prime. Next point is negative 6, negative 3. Gives me C prime. And then negative 3, negative 3, left 3, up 3, gives me D prime. So I'm going to fill in my lines between my coordinates to show the parallelogram. Okay, it wants to know the area of the image. So again, remember that whenever we're doing this, area is equal to base times height. My base here is going to be across the bottom, right here. And the distance for that base is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Okay, so I have base is 9. My height is going to be a perpendicular distance, so we're going to call this my height. So that is 1, 2, 3, 4, 5, 6 units. 9 times 6 will give us 54 square units. Oops, square. The area of the image is how many times the area of parallelogram ABCD and why. So, first of all, how many times is the area of the new image compared to the original? They're asking that 6 units times what is going to get me 54. To get x by itself, I'll divide by 6 on both sides, which leaves me that x is 9. So it'll be 9 times the original image. And it asks why. Remember, we had that scale factor of 3, and whenever we're talking about a way to remember it, okay, we have a scale factor of 3, and our units for area are always squared. So I'm going to take that scale factor of 3, I'm going to square it, and that will get me that 9 times bigger because each side is going to be multiplied there. So, homework for today is from Lesson 60, A through F, and 1 through 17. Mr. Wood, if you'll please write this assignment on the board for them, they will appreciate it forever and ever. Be good, please. Where's it at?